Let's talk about microplastics. Why do scientists believe they could be the culprit?
Microplastics, when digested, there are, lots of data there can lead to estrogens, lead to hormone production, changes in hormones within the body. And some of those hormonal changes can lead to inflammation. So there has been description of microplastics actually found in our organs, in the heart, in brains, literal deposits of microplastics. We know that they are everywhere in the environment. Even people who don't eat red meat, they're all over the ocean. They're in the fish we eat. We know that there are general shifts in the hormones, presumably from microplastics. There has not been a direct link, but that's certainly one of the, I would say, very high up on the sort of ladder in terms of suspects. But it's very, very difficult to demonstrate the changes from just ingesting these microplastics, A, that we're truly ingesting them, that they exist, and then secondarily, that all of these changes lead to cancer. And I think an even more important and tougher question is, if this is something that we're all exposed to, why are these individuals, certain individuals, developing cancer and others are not? So there is still very likely some group of individuals that are predisposed. And so I think those are the key things that we need to think about when we do research is, what are the culprits potentially that are causing these changes in our bodies, and then who's more susceptible to actually developing a cancer from those changes.
There is, I know, some thinking that microplastics may be piercing the microbiome somehow. The microbiome seems to be the real key to understanding this, right?
We think so, we think so because it's really a whole world, right? The microbiome, it's not just sort of these are our bacteria, but it's in the interaction between the bacteria, how they protect us, how they help us. And so that's why this microbiome is under such investigation. The issue is that there are a lot of things that can change our microbiome. It's dynamic. It's a huge universe. It's very different, from if you're eating something, you're used to a diet on the East Coast of the US and you travel, let's say, to Asia. There have been studies that have shown that within a week, the microbiome that we can identify changes drastically. So it's a very, very hard thing to kind of capture, saying, okay, this is definitely the culprit. This is what these are the changes, these are the bacteria that the patients has. But we are starting to see some signs that there might be some bacteria that some of these young patients do have in common, that could perhaps have led to this. So we're making some progress, but it is a really sort of, I would say, like, as big as the microbiome is, it's hard of a question, to tackle.